Internal division of line segment. Well, in the previous video, to make it very simple, I had taken a horizontal line PR and then we found a coordinates of the point D which could divide internally the line segment. Now, well, it was probably too simple. Now I complicated it a bit. So we'll go a step ahead and understand what it really means to divide a line internally and how to find the coordinates of the point. So the question here is, find the coordinates of the point D that divides the given line segment PR internally in the ratio of 1:2. So since we have a coordinate plane here, it's kind of simple. Well, we can divide this line into 3 equal parts. 1:2 we need. So first part is this one, leaving aside 2, we get the point D here, right? So that is how we can easily get our answer, and we know coordinates of point D are 1, 2. Done. So if a coordinate plane is given to us, is that simple. So the concept is, take a line, divide it into number of parts, which is sum of those ratios, and then easily we can pick up the point. Now how to do this as an exercise for vectors, that is what we are going to explore. Now for vectors, as you know, points, we can treat these points as position vectors. So what we will do is, we'll refer to origin, and let's consider O as an external point, and from O we will draw the vectors OP and OR. So we have these vectors now which are OP and OR, right? Let me draw it with the dotted line first. Okay, so good enough. So let me just join it. So we have OP and OR, and what we need actually is somewhere in between a point D which divides the line PR in the ratio of 1:2. Now the question is how to find that point. So now we'll use the concept of vectors to find the point D. We already know our answer, right? The answer is 1, 2. Let's see how do we get it. So now we can say that D, let's say what is PD? PD can be written as is a scalar multiple of PR, correct? And if PR has a length of 1 plus 2, which is 3, then PD is 1, right? So it's 1/3 of PR. So I can write this as 1/3 of PR, right? So that's how we get PD. Now PD could also be written in terms of OD. We can say PD is OD minus OP. So we can write this as OD minus OP is 1/3 of PR, and PR can be written as OR minus OP. OR minus OP. Correct. Now from here we can find the position vector OD. So OD is equals to, let's expand this, we have 1/3 of OR minus 1/3 of OP, and we bring it here, we get plus OP, right? So we get OD, the position vector. With that will give us the coordinates also, right? So let's combine these two terms. We get 1/3 of OR minus 1/3 from plus 1 gives us 2/3, right? So it is 2/3 of OP. That's what OD is. Now we know what is OR and we know what is OP. OP is 0, 1, right? So OP is 0, 1 and OR is 3, 4 for us in this given scenario. So we'll utilize these points and find the coordinates of point D. So we can write this as 1/3 OR is 3, 4 plus 2/3 of 0, 1, and that gives us 1/3 of 3 is 1, 4 over 3 plus 0, 2 over 3, right? And that is 1, and 4 over 3 plus 2 over 3 is 6 over 3, which is indeed 2. So vector OD is 1, 2, and that means point D should be what? So from here it's very clear, that implies that point D basically is 1, 2, right? From origin, I wrote is 1, 2, right? So that is our answer. So we can now write down our answer as the point D that divides the given segment PR in the ratio of 1:2 is 1, 2, right? And that's the vector way of doing it, right? Now this is such a beautiful method that it could be adopted whether you have a 2D or R3, it doesn't matter, right? So you could adopt this method in solving any problem. Given 2 points which will form a line segment, if you need a point D within this segment to divide it internally, we can easily find that point using this method, right? And in the last video we derived a general equation also, which I can write now here also from here, right? Which is, we can say OD is basically equals to, when we say 1/3, basically you got 1 over these two, right? Let me write this ratio as m:n. In that case this will be m here and that will be n, right? So we can write this as m over m plus n times OR plus n over m plus n times OP, right? So that becomes a general formula which can be applied. We'll see in the coming videos that actually D could also divide the line PR externally. That means we could take it here and then divide. In that case, the only thing is n will be treated as negative because it will be kind of like this. If you see PD in one direction is positive, then coming back will be negative. So n part will be treated negative. So if you replace n with negative n, you get formula for external division also, right? So we'll explore that in coming videos. Well, you can always try it out and get that formula if possible. That'd be great. Thank you and all the best.